Good morning, boys and girls, and welcome back to derivatives of trigonometric functions. All right. Today we're going to start off with a quick little review of some limits we said that we should know. Well, at least one limit we said we should know, and I'm going to give you another one that is kind of handy sometimes, but I don't know if you need to have it as memorized as the first one. Okay. So the first one we said we absolutely need to know the limit as x approaches 0 of sine x over x. You should all know, be saying out loud, hey, that is 1. Okay. We should know that one. That one is super important. This other one is I want to say like almost as important. We don't see it come up quite as much as far as the AP exam is concerned. I've never seen it on the AP exam, but it's another kind of like, famous one like this one that I think is handy to know. So if you're looking to add another limit to your repertoire, I would add this one right here. But it's the limit as x approaches 0 of cosine x minus 1 over x. And this is going to equal 0. Again, like the first one, it's one of those ones that's kind of hard to think and find. If you remember when we did the first one originally, we did it numerically and added values. And you can do the same one the same way. All right. Now that we have kind of reviewed those two limits, what we're going to do is we're going to try to derive the derivative of sine. Okay? If you remember back in the very first section, I believe it was, or second section, when we first talked about derivatives, I told you that the derivative of sine was cosine, but we have talked about how all derivatives are based from limits, right? All derivatives come from the limit definition, or one of our limit definitions. One being the limit as h approaches 0 of f of x plus h minus f of x all over h, right? Anything we do with derivatives comes from that definition right there, that limit definition. So let's go back now and let's see if we can't derive what the real, what the derivative of sine x is. Okay, so we're going to take the derivative of sine x, but we're going to do it through our limit definition. I'm going to show a bunch of the work here, and then we'll go back and talk about it. But so that you don't have to sit and watch me write down all these steps, I'm going to pause the video and have them pop back up magically. Okay, so let's get started here, at least just a little bit. Again, we're using that limit definition. The limit as h approaches 0 of f of x plus h minus f of x all over h. I'm trying to take the derivative of sine x. So f of x in this case, why isn't it writing here? F of x in this case is sine x. So sine of x plus h, I'm just plugging x plus h in, minus sine of x all over h. That's how we start. Then you're going to use a trig identity. I'm going to be real honest. I don't have this one memorized, and I don't think you do either, and that's okay. But you should know that there's an identity that we can use and be aware of it and know where to look it up. In this case, I pulled this one off the, it's in the front of our book. So I pulled this identity out, and I could rewrite sine of x plus h as sine x cosine h plus cosine x sine h. Remember, it's that one that went like sine alpha cosine beta plus cosine alpha sine beta. If you look it up in the book, it'll be right there. Then all minus sine x over h. And now I'm going to have to rearrange and do some rewriting of this. Okay, so I slid things around here, and this is where we kind of left off. Sine x cosine h plus cosine x sine h minus sine x over h. And then I just rearranged things a little bit, and I moved, sine x cosine h minus sine x plus cosine x sine h all over h. And then I factored out a sine x from the first two terms. And I rose at this step right here. And then I just kind of rewrote this step so we can see what's going to be happening a little bit better here. The sine x cosine h times cosine h minus 1 over h plus cosine x minus sine h over h. Or sorry, not minus. That's times sine h over h. That does kind of look like a minus. Times sine h over h. These are both times here. So I just kind of rewrote that step we had above just so it looks, we'll kind of be able to tell what's going on with it a little better. Because now as we look at this limit as h goes to 0, in the front, this cosine h minus 1 over h goes back to that first rule we just got done reviewing, the cosine x minus 1 over x. And we said that, hey, if we take the limit of that as that goes to 0, this whole term is going to go to 0. So I end up with sine x times 0, which is 0. And then 0, 0. And then in the back here, I've got the sine h over h. And we said the limit as h goes to 0, or the limit as x goes to 0 of sine x over x goes to 1. So this is going to go to 1. I get cosine x. So then if I do this, I'm going to get 0 plus cosine x or just cosine x. And like we know, the derivative of sine x is cosine x, but now I've proved it through the limit definition. Okay? And that's, again, even though we don't do this for everything, I want you to see that's where all derivatives come from. It comes from this limit definition. All right? Okay, so we just found the derivative of sine x is cosine x with the limit definition. I can do that with cosine x too, and you're going to see some of those same rules coming up. I mean, if you're bored and wanted to prove that the derivative of cosine x is negative sine x, that might be a fun activity. It's just like the one I just did. But I'm not going to put you through that suffering. Instead, we're going to move on to the derivative of tangent of x. And again, I could go back to the limit definition, and I could prove, I think fairly similar to the way we've done that first one, that what the derivative of tangent x is going to be. However, I'm going to do this slightly different this time. I'm going to come to the kind of an informal proof of the derivative of tangent x, and I'm going to do that by just redefining tangent x as sine x over cosine x. Okay. Now, if I want to take the derivative of tangent x, sine x over cosine x, I have to use the quotient rule. So if we're using the quotient rule, I got low d high minus high d low. Derivative of cosine is negative sine. Square the bottom, and off we go. Okay. And then I can put this together. Cosine times cosine is cosine squared x. Negative sine x times negative sine x is positive sine squared x. All over cosine squared x. Hopefully we're seeing, hey, cosine squared x plus sine squared x. Hey, that's like 1, using our Pythagorean identity, over cosine squared x. And 1 over cosine squared x, 1 over cosine is secant squared x. Okay, so the derivative of tangent of x is secant squared x. Now you can see this was not that bad. If you ever get lost on any of our trig derivatives, the reason I'm showing this to you is you can always go back and rederive the derivative, okay, by using the quotient rule. However, I'm about ready to give you all of our derivatives, and that you just want to have them memorized, okay? So here we go. Let me put all the derivatives to all the trig functions up, and then you can write them down. Okay, so here are our 6 trig functions and their derivatives. The derivative of sine x is cosine x. The derivative of tangent of x is secant squared x. The derivative of secant x is secant x tangent x. I kind of went through them in this order, okay, because you need to memorize all 6. But I'm going to say you really need to memorize 3 of the 6. And if you get these 3 down, then the next 3 kind of come fairly easy, okay? Because the next 3 are just the negative co-functions, okay? So, like cosine is the co-function of sine. So the derivative of cosine of x is negative its co-function sine x. Good? The derivative of cotangent x is negative if you know this one, this was secant squared x, so the co-function of secant squared x is cosecant squared x. So negative cosecant squared x. The derivative of cosecant of x is negative, and always negative the co-function, and then this was secant x tangent x, so their co-function would be cosecant x cotangent x. Okay? So that's how the trick I use to help me memorize these. Hopefully that helps work for you, but you just want to have these 6 down. For sure, the derivative of sine, derivative of cosine, derivative of tangent, and the derivative of secant, those 4 for sure pop up all the time. Okay? But if you get these 3, I really think you can get the other 2 over here too. It's not that big of a deal. Okay, but all are fair game on tests and or quizzes on the no calculator part. Okay? All right, moving on now. Okay, so here's our first problem. The limit as x approaches 0 of sine 3x over tangent of 4x. I want to evaluate this limit, so I'm going to have to do some rewriting of this. So my first step was to rewrite tangent of 4x as sine of 4x over cosine of 4x. And then, because I'm dividing fractions, I can flip that guy and multiply. So I can really rewrite this as the limit as x approaches 0 of sine 3x cosine 4x over sine 4x. Then I'm going to want to use the fact that, again, if I have like sine u over u as the limit as x goes to 0, that's going to go to 1. So I'm going to want to multiply the bottom by 3x to get that sine u over u, and the top by 4x to get that sine u over u. The only thing is I need to multiply the top and bottom by the same number. So I'm also going to have to multiply the top by a 3 and the bottom by a 4. So I'm really multiplying the top and the bottom by 12x. Okay, but now I'm multiplying the top and bottom of this thing, so I'm really not changing anything. And now I'm going to rewrite this so it looks a little bit different and we can work it all out. Okay, so on the top I got that extra 3, my sine 3x, the 4x, cosine 4x. On the bottom I've got that extra 4, the 3x, sine 4x, and then just a 1 there. So now as I look at the limit as x approaches 0, sine 3x over 3x is going to go to 1. 4x over sine x is going to go to 1, again, because it's that same thing. And then the limit as cosine goes to 0 is also 1. So I get 3/4 times 1 times 1 times 1. And so this whole thing is going to go to, not 1, there's a 3/4 there. It's going to go to 3/4. So that's how I'd want to work this thing out using some of those rules that we have talked about. Okay, next I want to take the derivative of y equals 5x squared plus cosine x. So take the derivative of this, way we can write the derivative dy dx, taking the derivative of y with respect to x. I'm just going to take the derivative of the first term using my power rule, 10x, and then I've got to take the derivative of the trig function. Hey, derivative of cosine is negative sine x. So if you have these memorized, that'll speed things up. You might need to look at them as you're doing them tonight, but you're eventually going to want to have this stuff down and memorized, these trig function derivatives. All right, next one here, y equals cosine squared x, getting a little bit trickier. Couple things with this cosine squared x is really cosine of x squared, right? That's what that means. And I can't take the derivative of a power yet. We haven't talked about how to do that. That's going to be the chain rule, and that's something we're going to get to here in a little bit. So this one, though, we have to talk about, if I had something like this, I would have to rewrite it as cosine x times cosine x, and we are going to have to use the product rule to take the derivative. Okay, so using the product rule, derivative of the first, negative sine x, times the second, cosine x, plus the first cosine x times the derivative of the second, negative sine x. Okay, for our product rule. Putting those together, I'm going to get negative 2 sine x cosine x. And again, we're going to make sure you're checking your answers in the back of the book. If I check this one in the back of the book, they're not going to have that answer. Okay, they did not. I need to keep in mind against some of my identities, and this one we said you need to be familiar with. If you see 2 sine x cosine x, know that that's the same thing as sine 2x. So this would be the same as negative sine 2x, and that's the answer they actually had in the back of the book. But we need to be able to move things around like that. Okay, next problem here, y equals tan w over 1 plus tan w. Here, if we're going to do this, we need to use the quotient rule. So I'm going to go ahead and do that. All right, so low d high, derivative tangent secant squared w, minus high d low. When I take the derivative of low, derivative of 1 is 0, and derivative tangent again is secant squared w. Square the bottom, and off we go. All right, again, technically up there at this step here, we have found the derivative, but I got to start making it try to match the back of the book. So again, common thing to do is have to factor out a GCF. So I factored out a secant squared w, and inside that left me with 1 plus tan w minus tan w. And then the tan w's kill each other off, leaving with just 1. And so 1 times secant squared w is just secant squared w. And so here is the derivative to that function. But make sure you're trying to work to the answers in the back of the book. Okay, last problem here. I want to take the derivative of y equals e to the x sine x. We're going to have two functions multiplying to each other, so I got to use the product rule. I think that's where things start to get a little bit tricky, is when we get rules upon rules that we're trying to keep straight in our heads. All right, so product rule. Derivative of the first, derivative of e to the x is e to the x, times the second, sine x, plus the first, e to the x, times the derivative of the second, negative cosine x. All right, again, technically I've now found the derivative, but I think I probably would have to pull out an e to the x here if I'm guessing. And so that leaves me with, sine x minus cosine x. And the more you'll get a feel for how answers are probably going to look, but then go and check yourself at the back of the book. Okay, looking in the back of the book, I realized I made a couple of mistakes here. One, when I took the derivative of sine x, it said it was negative cosine x. It should be positive cosine x. Trying to be under 15 minutes, and I'm getting crunched for time here. That caused that mistake, so that really should be a plus. But then I also notice I'm supposed to find the second derivative. So if I take the second derivative, here is your second derivative, the derivative of the one up on top, using the product rule twice. And when I do this, I end up with 2e to the x cosine x.